This looks like something from a distant planet or a fever dream of science fiction, but it's real. It is happening right now, on our own world. To find it, we must leave the blue world we know, descending past the sunlight of the epipelagic zone, down into the twilight zone, where light fades to gray, and finally into the midnight zone, the bathypelagic, where the sun has not shone for millions of years. Here, the conditions are hellish. The water temperature hovers just above freezing, and the pressure is crushing. Imagine an elephant standing on your thumb. That is the weight of the water pressing against every square inch of life down here. Yet, incredibly, life thrives. In this eternal night, photosynthesis is impossible. Food is scarce. Most creatures rely on marine snow, a constant drift of organic debris, dead plankton, and waste falling from the rich surface world miles above. A silent, never-ending feast for the scavengers of the deep. But the dark is not empty of light. In fact, it is alive with it. 75% of deep-sea animals make their own illumination. Bioluminescence, a chemical reaction inside their bodies that produces cold fire. It serves many purposes. For the vampire squid, it is a defense. When threatened, it ejects a cloud of glowing bioluminescent mucus. This dazzling display confuses predators, acting like a burglar alarm in the dark, buying the squid precious seconds to escape. Then there are the monsters. Deep-sea gigantism is a phenomenon where creatures grow to massive sizes compared to their shallow water cousins. The giant isopod, a scavenger the size of a cat crawling across the sediment. And the most famous giant of all, the colossal squid. With eyes the size of basketballs, the largest in the animal kingdom, evolved to spot the faint glow of predators in the gloom. A body built to survive where metabolism must be incredibly slow to conserve energy. Deeper still, we find an ecosystem that defies the rules of biology. The hydrothermal vents, black smokers spewing mineral-rich water heated by magma from the Earth's crust. Temperatures here can melt lead. Yet life is here too. Giant tube worms with no mouth and no gut. They rely on bacteria living inside them to convert the toxic chemicals into energy. Chemosynthesis, an alien ecosystem right here on Earth, proving life can exist in the most hostile environments imaginable. This world is also a time capsule. For millions of years, the deep ocean has remained unchanged. The coelacanth, a fish thought to have died out with the dinosaurs 66 million years ago, was found alive here in 1938. It is a living fossil, swimming through history. And the goblin shark, a creature of nightmares with a jaw that can shoot out of its face to snatch prey. Its lineage goes back 125 million years. It has patrolled these dark waters since the Cretaceous period, unchanged, perfectly adapted to the dark. But it's not just nature down here. We have left our mark too. On April 15, 1912, the Titanic sank. In 1985, we found it, resting 3,800 meters down, a ghost ship in the eternal night. Its grand ballroom silent, its passengers long gone. But even steel cannot last forever here. The ocean is claiming it back. A unique species of bacteria, Halomonas titanicae, is slowly consuming the iron rivets of the ship. These rusticles are eating the Titanic. Scientists predict that within a few decades, the wreck will collapse entirely, returning to the seabed. Our quest to reach the bottom began decades ago. On January 23, 1960, Jacques Piccard and Don Walsh made history. They climbed into the Trieste, a bathyscaphe designed to withstand ultimate pressure. Their target, the Challenger Deep. As they descended past 30,000 feet, a loud crack echoed through the sphere. The outer window pane had fractured, but they made the choice to continue. For hours they fell through the darkness, putting their lives in the hands of engineering. At 11,000 meters, 7 miles down, they hit the bottom. They stayed for just 20 minutes, but in that time, they saw a flatfish swimming away. They proved that even here, under 8 tons of pressure per square inch, life exists. Yet, the ocean keeps its secrets. In 1997, hydrophones across the Pacific picked up a sound. They called it the bloop. It was ultra-low frequency and incredibly loud, heard over 3,000 miles away. Was it a massive ice quake cracking the Antarctic shelf, or was it a biological sound from a creature larger than a blue whale? We still don't know for sure. Now, humanity looks to the deep for a different reason. Treasure. Scattered across the abyssal plains are polymetallic nodules, potato-sized rocks rich in manganese, nickel, copper, and cobalt, the building blocks of our electric future. The Clarion-Clipperton Zone holds billions of tons of these metals. Deep-sea mining could power our green revolution, but scientists warn it could destroy fragile ecosystems we haven't even discovered yet. The sediment plumes could choke life for miles. The debate over the deep has just begun. For the creatures down here, the surface is as hostile as space is to us. They are trapped by pressure, protected by distance. If brought up, their bodies would disintegrate. We are separated by an invisible barrier of physics. We know more about the surface of Mars than the bottom of our own ocean. It is the final frontier on Earth, a world of monsters, ghosts, and treasures. What else is hiding in the dark, waiting for us to turn on the lights? If you enjoyed this deep dive into the unknown, subscribe to WTFiction. We post long-form documentaries every week exploring the strangest corners of our reality. What deep-sea topics should we cover next? Let us know in the comments below.